All right, everyone. This is 3.1 addition and subtraction problem types. I'm going to go over pretty much all the types and the subtypes again, just in case you guys needed to hear it back. And at the end, we'll do some examples. And of course, if you have more questions about this, come to my office hours, Tuesdays, Thursdays, 3 to 4:30. I sound like a robot. But yeah, feel free to speed up this video, use it however you need it. So let's jump in. So we have four um, three main types. Uh, I'll I'll um I'll explain why it's three, not four. So we have our join problem. So basically, it's just your additions, right? And then we have our separate problems. So join, usually people also, your textbook says add two problems. Separate problems are your take from problems for your subtraction problems. Um, part whole has two main types. That's why I'm like three, four. Part whole, you have the put together, take apart problems, and you have the comparing problems. So each type has a subtype. For the join problems, we have the result unknown, and we have the change unknown and the start unknown. As y'all can see, that's the same subtypes for separate. But for the part whole, they're called different because they're different. So yeah, so let me explain to you guys. So the result unknown is pretty self-explanatory. You just have two things that you add together, and then you don't know the final result. For example, in this problem, it says Rachel had 23 CDs, so you start off with 23, and she got 18 more. So that's clear that it's addition, right? How many does she have now? So because we're looking for the result and the operation in this problem is addition, then we call this a join result unknown problem. And you can represent that like this. We talked about that in class. And then we have the change unknown. The change unknown is kind of tricky in the wording because I get why it can get confusing because it is a join or an add to problem, but why is the change unknown? So let me clarify that for y'all. So look at this problem here. It says Rachel had 23 CDs, so that's how many you start with. After she gets some more, we know that's an addition problem, right? Even though we don't know how many we're adding. And then she had 41 CDs in total. How many CDs did Rachel get? So we know the total, so the result we know. We just don't know what we add 23 with to get to the total. That's why it's a join problem and it's the change unknown. So you can think of it like, I don't know, like you can think of change unknown in the join problem as like an add-in unknown. I don't know what to add 23 with to get 41. Now, um, this section here, why is there a subtraction and a join problem type? This thing here is just to show you how to solve because like this is the number sentence for this problem, right? And this is the number sentence for this problem. So this is the equation to solve the add-in unknown or the change unknown. So that's why we subtracted 23 from both sides so that we can isolate the square there to find what it is. And the representation here, again, we start with 23 and we're adding with something, but we know that the result for the total of the sum is 41. That's why it's a join change unknown. Okay, and the start unknown, it's in the name. We don't know what we're starting with, but we're adding something that um, we know the value of. Okay, So it says Rachel had some CDs after she got 18 more. So Rachel had some CDs after she got 18 more. So that's just saying I had some CDs and then I'm going to add 18, right? And then at the end, Rachel had 41. How many CDs did Rachel have before? So we just don't know what she started with. That's why it's called start unknown. Again, we started with some, then we added 18. In total, we have 41. We have this second formula here because we want to know the solution, right? But your number sentence was still the start unknown plus 18 equals 41. Okay. All right, so let's go to separate. The result unknown is the same idea, but it's different here because we're talking about subtraction. So subtraction, subtraction. Okay. So the result unknown problem says Rachel had 41 CDs, so we know what we started with. She gave away 23. She gave away, so that means a subtraction 23. How many does she have now? So we're given what she started with and then what we're taking away with, but we don't know what the result is. That's why it's called the result unknown. And subtraction implies separate problem. So yeah, again, we know what we start with. We have 41 in total. From that 41 pool of CDs, I'm going to take away 23. And then we need to know what's left, right? Okay. Then the change unknown, again, like we don't know what we're subtracting with, but we know what we start with and what we end up with. So that's why we call it change unknown. So it says Rachel had 41 CDs. After she gave some away, so we don't know what some is, and she had 18 left. How many did she give away? So in that case, because we know the starting point, we don't know what we took away, but we know what we end up with, which is 18. That's why we call this change unknown. Okay. Similar to join problem, there's a separate start unknown. So in this example, it says Rachel had some CDs, so we don't know how many she started with, but after she gave 23 away, she had 18 left. How many CDs did Rachel have before? So after she gave 23 away, to take this away, she has 18 left. So how many did she start with? So we have to go backwards, right? That's why this is starting unknown. We're taking away, and then we know the result. So this is the number sentence. So as y'all can see, like there are solution equations here because we want to solve for what we don't know. In this case, the change unknown. So we subtract 18 from both sides and then add the square to the right. That's why we get 41 minus 18 equals square. And then on this one, we added 23 on both sides so that we can get the square. Okay. All right, so now we go to part whole. We have two types put together or take apart problems and compare problems. So let's dig into the put together or take apart problems. So we have the total unknown, we have the add-in unknown, and then we have the both add-ins unknown. Okay, total unknown. Here's the example here. Rachel has 23 hip hop CDs, 18 rap CDs, and no others. How many CDs does she have in all? Okay, so you can think of it as, I think I mentioned it in class. Do you notice how we have two different types of things, but they're all, so like we have hip hop and rap, but if you combine them all, they're all CDs, right? So that's why like we're putting it together. And then the add-in unknown, um, we, we have Rachel has 41 CDs. If 23 are hip hop and the rest are rap, how many rap CDs does she have? So again, you can demonstrate that with a math drawing. We have the total, and then we have the hip hop, but we don't know the rap, right? So what you do, you're going to subtract 23 from 41 because we need to know what's left, which is the rap, right? The rap CDs. So as you can see, like this is familiar, right? This is the total unknown is similar to the join result unknown. Can y'all see that? So what's the difference between part whole and join result unknown? Look at the problem. This one said Rachel had 23 CDs. She got 18 more CDs. How many does she have now? For the put together take apart problems, we have two different things. Like we're saying that hip hop CDs and rap CDs are a part of a bigger set of CDs. So we're putting them together. That's why we call this a part whole. Notice the units, right? So hip hop CDs and rap CDs are within the CDs category. That's why this one is labeled part whole, total unknown. Okay? And at the same time, the add-in unknown in the part whole is similar to the change unknown in join, right? Again, what's the difference? The units, because in join change unknown, we have 23 CDs added with some CDs, you get 41 CDs in total. But in the part whole, the add-in unknown, we're saying this bigger part of the CDs, we have a hip hop and rap categories. We know how many there are in hip hop category, which is 23. We just don't know what in the rap category. So you can think of it like if the add-in unknown has two subunits, in this case hip hop and rap CDs, within a bigger group of CDs, that's a part whole. But if you're using just one unit, just CDs, simply CDs, right? That's join problem, join change unknown. Yeah. All right, so a new thing is called both add-ins unknown. So in this case, the problem was Rachel has 7 CDs and 2 boxes to put them in. So imagine 2 boxes. These are not boxes, these are squares. 2 boxes, and she has 7 CDs in total. I'm just gonna put circles. Okay. How many CDs can she put in the boxes? So you have to find the combination of, like, for example, I can put all 7 CDs in one box and none the other, or 2 in one box and 5 in the other. So for part whole, again, you just need to, for the both add-ins unknown, it's like you're filling up the add-ins, right? Yeah, I think this one is really straightforward. Yeah, so that's part whole. All right. So last type, compare problems. So compare problems, in my opinion, is easy to spot because literally what you're doing is comparing. So we have 3 different types: difference unknown, bigger unknown, and smaller unknown. Let's look at the difference unknown. So it says Rachel has 41 CDs and Benny has 23 CDs. Do y'all see, like, we're already comparing these two people's CDs, a collection. So there are 2 versions. So version 1 says how many more CDs does Rachel have than Benny? So how many more CDs does Rachel have than Benny, right? So we know that Rachel has 41 we need to know, like, from Benny's amount of CDs, how many more do we add so that we can get to Rachel's amount of CDs? That's the first version of how you can phrase this, with the how many more. The second version that you can rewrite this question is how many fewer. So, how many fewer CDs does Benny have than Rachel? Basically, you want to know the difference between Rachel and Benny's, right? We're putting Rachel's CDs in the front because it's bigger. We subtract it from Benny's. So the change or the difference will tell us how many fewer CDs does Benny have than Rachel. So it really matters how you phrase your questions. Yeah, think of it when you're creating problems for your students. You have two options just for the subtype, the difference unknown. All right, so the bigger unknown, they only give us the information of Benny has 23 CDs, right? So version 1 says we want to use the word more. So it says Rachel has 18 more CDs than Benny. So we know from the beginning that Benny has 23, right? So we add 18 to that 23. So how many CDs does Rachel have? Okay, hold on. Benny has 23. Rachel has 18 more CDs than Benny. Oh yeah, so um we need to know how many CDs does Rachel have. We're only given the information of Benny's total, and then the information that Rachel has 18 more than Benny. So we need to add that. So we know by this question that Rachel has more than Benny, right? And then 2, again, Benny has 23 CDs, but they also say Benny has 18 fewer CDs than Rachel. How many CDs does Rachel have? So if Benny's is 23, and that's 18 fewer than Rachel's, we know that Rachel's CD collection is bigger again, right? But the way that you phrase it changes how we write the number sentence. But do y'all notice that we arrive in the same answer? 23 plus 18. This is how I do it in my head. I'm gonna do mental math right now. 20 plus 10, and then you add the ones, right? So that's 30. 30 plus 8 plus 2 plus 1, that's 41. And for this one, I think of it as the same thing as that 23 plus 18. So this is 41 as well. Yeah. So even though these two questions use different words, like different wording, we do arrive with the same answer. But as y'all can see, the number sentence is different, right? That's why it matters why we should know the different types of questions. Okay. All right. So last but not least, again, it's the compare problems for smaller unknown. I guess y'all can already guess it. Rachel has 41 CDs. That's one of our clues or what's given. And then there are two versions of these where you use the word fewer or you can use the word more. So you can phrase it this way. Benny has 18 fewer CDs than Rachel. How many CDs does Benny have? So if Benny has 18 fewer CDs than Rachel, Benny has smaller amount of CDs, right? So that's why it's called the smaller unknown. Like we're asking for Benny's, right? So we know that 41 is Rachel's and Benny's is 18 less than that. Okay. All right. And then let's say you want to use the word more. Again, we're asking about the same things, but we're just wording it differently. So it says again, Rachel has 41 CDs and Rachel has 18 more CDs than Benny. How many CDs does Benny have? Again, we know that from this wording, Rachel still has the bigger collection, right? We just need to know how many Benny has. What's given to us is still the same. In this way, Rachel has 18 more CDs than Benny. Do y'all see how these sentences that I'm circling are saying the same thing? But um, if you put it together, like Benny has 18 fewer CDs, that's why we subtract it because of the word fewer. But because we phrase it that Rachel has 18 more, that's why we use addition. Yeah. So yeah, I know this will take a minute or a few minutes to really um just, to like for you to process it, but I recommend that you practice through the homework. And as you can see, like we've been doing different activities in class using these vocabulary, right? So I want you guys to pause the video and do these two problems. Okay, make sure you do them. All right, so let's do number one. It says write a join, change unknown problem. So go back to your notes, join, change unknown. So I'm talking about this. Okay. All right. So for me, when I'm creating a problem, I like to write my number sentence first. It could be different for each person, but this is just my preference. Let's say I want to do 8 plus something equals to 14. Okay. I know that this is a join problem because it's an addition. A change unknown because I don't know what I'm adding 8 to get 14. So the add-in is unknown here. All right, so y'all ready? I'm gonna put Peter. Peter has 14 Legos in total. That's a very small amount of Legos, but okay. And 8 of his Legos are red, and the rest are blue. How many blue Legos does Peter have? Yeah. If I were to cover this up, this number sentence up, I'm gonna rewrite the number sentence here. Peter has 14 Legos in total. So that's my signal knowing I know the result. So this is not a result unknown problem. So I know 8 of them are red, and the rest, when they say the rest, so I know I'm adding to something, are blue, right? So that's why it's a join because it's an addition, and change unknown because I don't know what I'm adding 8 to get to 14. Okay, hopefully that clears things up for y'all. Okay, so how about try number two? It's a join problem, start unknown, and create a problem based on this number sentence. Okay, I know you did it. But so let's say Paula I don't know why I'm starting with P as the name here. But Paula also had some Legos. And her brother, Peter, well, it's just and her brother, gave her 7 more Legos. And now Paula has 15 Legos in total. How many Legos did Paula have at first? So when you're teaching this, you might have to clarify what you mean by at first. You could say, um, well, how many Legos did Paula have before her brother gave her some Legos, right? You could even add some more context, like, um, for her birthday, like, her brother gave her 7 more Legos. So how many did she have before her birthday? Something like that. It's up to you, but you know. So yeah, again, pretend that I didn't have this number sentence. Let's just read this problem here. Paula had some Legos. So anytime you hear that ambiguous, like it's not specific, draw a box. Something that we don't know, right? Star unknown. We don't know what she started with. And then her brother gave her 7 more Legos. Gave her 7 more. That's an addition, and then by 7, right? Now Paula has 5 Legos in total, so we know the result. So by this, we know it's a join problem and it's a start unknown problem. So you can apply that to separate problems as well. Like you need to just read the whole thing. Like don't take it apart like, oh, I'm just going to write what's here and then it might confuse you. Just like read the whole thing and then you can take it apart one by one. You need to know the whole context. That's what I meant. Okay? All right, so this is our last one for this video. Wait, no, last two. So go ahead and do that. Pause the video and do it. Okay, I know you did it. So for this one, we're going to do compare, smaller unknown problem. But I'm asking you to do 2 versions, where version 1, you will use the word more, and then version 2, you will use the word fewer. Are y'all ready? Okay, so Becky has 23 rocks. Becky's a rock girl, which is more than what Sam has. Sam is jealous. So how many rocks does Sam have? Okay. So in the instructions, like I wanted you guys to also think about the number sentence and the math drawing. So I would okay, first of all, this is a compare problem because we're comparing what two people have, right? That's the simplest thing about this. Like we know we're comparing Becky and Sam's collections of rocks. That's crazy, but okay. So yeah, draw it. Again, I'm not about to draw 23 rocks, y'all. So I'm gonna do a number strip. 23 for Becky, and that is wonky. Whoa, I don't like that. Okay, 23 for Becky, and then Sam. Sam's? Wait, did I specify how many? Which is more, which is 9 more. I should have, sorry, I had a note here. I didn't specify, which is 9 more than what Sam has. Okay, sorry, y'all. So in that case, we know that Becky has 9 more than what Sam has, right? So how much does Sam have? So how would y'all write that? So Becky has 23 rocks, which is more than what Sam has. 9 more than what Sam has. Which is 9 more than what Sam has. Okay? So yeah, that's my number sentence. 23 equals to something plus 9 more, right? Again, why is this one a compare smaller unknown problem? Again, we don't know. We know the bigger one, which is 23. We don't know what the smaller amount is, right? Yeah. And I'm doing addition in this number sentence because it says 9 more. Simply that. Okay. All right, so version 2. I'm gonna use Becky and Sam again. Um, okay, again, Becky has 23 rocks. I don't know how long this video is. My apologies in advance. Um, Sam has 9 fewer rocks than Becky. How many rocks does Sam have? Okay, I want y'all to compare. Pardon the pun, I did not mean that, but compare this situation and this situation. Does Sam have like the same amount of rocks as this problem, the version 1? Yeah, he does. It's just the wording again. So, what would I draw for this? The same thing as above, right? I'm gonna copy and I'm gonna paste. It's the same thing as above. But what's different is that the wording, right? So here it says 9 fewer rocks than Becky. So guess what I'm gonna do? We know Becky has 23. I'm gonna subtract 9 from it, and that's how many Sam has. Why is it different? Fewer implies subtraction, right? And that's why I put it here. So again, the 23 is the bigger, and we don't know the smaller, right? That's why it's called comparing a smaller unknown. Yeah. So I hope by now you're kind of like, okay, yeah, that's easier than I thought. It's in the wording, guys. Again, it's fine if it's like it's still confusing to me. Go see me. You're not in trouble or anything. It's just the wording. I just want you guys to be able to distinguish the difference between these two. Yeah, even though we arrive in the same answer, right? All right. Yeah. What else was I gonna say? Oh yeah. So think about it this way. Um, it's a funny analogy, but I don't know if this helps anyone. Think of it like is the glass half full, glass um half empty, right? So think of these two versions as that. Like we have y'all heard of that? Like, there are two types of people, they say. The people who see this glass, I don't even know if that looks, let's say that's half, okay? Um, some people, like half of the population, see it as like glass half empty or glass half full, right? It's like this is version 1, this is version 2. So some people say like people who see this glass as half full are like more positive, like optimistic people, and then people with glass half empty perspective has a more negative, I don't know, I think critical, I guess, view of life. So as you can see, like with the more and fewer, you can think of it like that. Like, Becky has 23 rocks, which is 9 more than what Sam has. So this has like to me, it sounds like, wow, Becky has more, so that's good. But the fewer version is saying like Becky has 23 rocks, but oh, poor Sam. Sam has 9 fewer. So I don't know if that helps. But anyways. All right, so last problem as an example. Write a separate change unknown problem that fits naturally with the equation. I'll let y'all do that. Okay, so I'm gonna change it to Nico has 23 uh, candies. Mhm. And after ate some, he ate some candies, and he is left with 9 candies. Sorry, I'm not writing full sentences here. How many candies did Nico eat? Yeah, so that's a separate because again, I'm gonna pretend that this is not here. Um, so we start with 23 candies. He ate some candies, so that implies I am taking away some candies. And he's left with 9. So because it's subtraction, it's a separate problem. Change unknown because I don't know what I'm subtracting it with. Yeah, that's it. So I hope that clear things up a little bit for y'all. But if you do still have questions for me, please come see me before the test. Again, the test is fast approaching. So yeah. All right, y'all. Have a good one.